Okay, tonight we're going to be doing Envisions 11-4, multiplying fractions. There's going to be two ways to do that. For the first way, we're going to multiply the numerators, then multiply the denominators, and if possible, we will simplify our final answer. Let's go ahead and do some examples of that. I'll show you. So if we have our first example, 3/4 times 7/8, we're going to follow our steps. First step says multiply the numerators. 3 times 7 equals 21. Second step is multiply the denominators. 4 times 8 is 32. Okay, so now it says simplify if possible. The way to determine if you can simplify is to see if they have GCF. So we're going to find the dancing pairs of 21 and 32. If you remember, for dancing pairs, that is what times what equals 21. Well, we have 1 and 21, and we have 3 and 7. Okay, for 32, we have 1 and 32, 2 and 16, 4 and 8. When we look at our lists, we can see that they have no factors in common except for 1. That lets us know that 21 over 32 is in simplest form. Okay. For our next example, we're going to show how it works even if you have 3 fractions. So if our problem is 3/4 times 1/4 times 2, we know from our last lesson that we need to put that whole number over the number 1, and then we go ahead and we first multiply our numerators. 3 times 1 is 3, and 3 times 2 is 6. Then we multiply our denominators. 4 times 4 is 16. 16 times 1 is 16. I know that 6 and 16 are even, and they can both be divided by the number 2. So I'm going to go ahead and reduce. 6 divided by 2 equals 3. 16 divided by 2 equals 8. 3 is a prime number that is not divisible by 8, so I know that 3/8 is in simplest form. Another way to multiply fractions is this. Before multiplying, we will simplify by finding a common factor of any numerator and any denominator. I'll show you an example of that next. For this example, we will be multiplying 3/4 times 5/6. Now you'll remember in the first way we would just multiply straight across and then reduce later. For this way, what we will do is we will try to simplify before. So I'm going to look and see if I have across here, if I can reduce 3 and 6 or 5 and 4 with one another. I know that 3 divided by 3 is 1 and 6 divided by 3 is 2. I cannot do anything with the 4 and 5, so I must leave those alone. Now I multiply across. The 3 has become a 1, so I have 1 times 5 is 5. 4 times 2 is 8. Simplest form. Two-thirds times 5/8. I look crossways and see if I can reduce. I cannot reduce 3 and 5. They're not divisible by the same number. But 2 and 8 both are divisible by 2. So I can reduce 2 divided by 2 becomes 1, and 8 divided by 2 becomes 4. Now I simply multiply straight across. 1 times 5 is 5, and 3 times 4 is 12. I know 5/12 is in simplest form because 5 is prime and also not divisible by 12. So my final answer is 5/12. Okay, let's do one more example of that. 2/9 divided by 3/10. This is a great one because as I look, I know that 2 and 10 are both divisible by 2. So 2 divided by 2 is 1, and 10 divided by 2 is 5. 3 and 9 are both divisible by 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. I multiply across. 1 times 1 is 1, and 3 times 5 is 15. Simplest form. So obviously, the benefit of doing it the second way is that you are already reducing before the numbers get too complicated to handle. So for the final part, we're going to show you how to use a model to show the multiplication of fractions. And I'm just doing this on notebook paper, as you can see. If my example is 4/5 times 3/10, and I'm asked to show a model, then what I need to do is first draw a diagram using shading to represent 4/5. Okay, so I'm going to go ahead and do that a little ways down. So I'm going to just draw a rectangle. And I know from my fraction, I know all the way back since first grade, right? I can divide that into 5 parts because the denominator tells me how many parts. 1, 2, 3, 4, and 5. So I have 1, 2, 3, 4, 5. The numerator tells me how many are colored in. So I'm going to go ahead and shade in 4. So you can see that 4/5 are represented by this diagram. The second step, we need to draw vertical lines using dots to show 3/10. So I'm going to take a separate color and I'm going to divide this figure into 10 groups vertically. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it's not the prettiest thing in the world. Then, so the 10 is represented because of the denominator. That shows me how many parts. The dots are the numerator, so it shows I have to color in or dot in 3 out of the 10 sections. So I'm going to go ahead and do that. Okay, so now you can see that I have dotted in 3/10 of the diagram. My next step is to count the parts that are both shaded and dotted. Okay, and that's what I mean right here. So shaded and dotted. Notice that these are only dotted, so I'm not counting them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 that are shaded and dotted. That becomes the numerator. Finally, I'm going to count the total number of parts. Sorry. In the diagram, and so in this case it is 50. That becomes the denominator. And again, I'm just counting literally every single one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so forth. So the fraction that represents this particular diagram is 12/50. And of course, as usual, you want to simplify if necessary. And 12/50 can be divided by 2, and it comes out to a final answer of 6/25.